Hey guys, okay, so today we are going to be talking about domain and range. Let's look at our we will statement. Again, this goes along with your anchor chart that should be in Unit 2, so please make sure that you are taking notes as we go. All right, we will determine the domain and range of a linear function in mathematical problems, determine reasonable domain and range values for real world situations, both continuous and discrete, and represent domain and range using inequalities. Okay, so that has a lot going on. So let's figure out what we're really wanting us to do. So we want to determine domain and range in math problems, real world problems. We're also going to talk about continuous and discrete. And then we're also going to represent domain and range using inequalities. So if you think about it, inequalities, those are these signs. So we have less than, greater than, less than or equal to, and then greater than or equal to. So we're going to use those signs. Now, there's a couple different ways that we're going to talk about domain and range. The first one is discrete. Okay, so discrete is going to be this first one right here. So I'm just going to write discrete. That's when we're going to list domain and range as a list of numbers. Okay. When we talk about domain, we need to understand that domain represents our x values and range is our y's. Okay. All right. So let's get into it. So first, we want to represent domain and range as a list of numbers. Here we have a list of ordered pairs. And I already mentioned that domain is our x values. So when we list domain as a list of numbers, it's just simply all of our x values that we are going to list. And really, that's about it. So let's go ahead and write those down. So we have 2, we have 7, -3, we have another 7, and then we have 5. And there's our domain listed as a set of numbers. Range is going to be my y values. So I have 0, -1, -7, -4, and -3. So again, we are going to just list them. So domain was our x values, and I might write that out here. And range is our y's. And this would be representing a discrete function. So the easiest way to remember discrete is that it can be counted. So for example, people are going to be a discrete function. Anything that can be counted versus a continuous function that deals with all different kinds of numbers. And so we'll look at that as we go. All right, let's keep going. So domain here, now this is a mapping. So we've talked about mappings before. Really the easiest way to do this is I'm going to make a table, and then that way it's a little bit easier to see. So -9 pairs up with 8. As you can see, the arrow is drawing it to there. And then we've got -8, and it pairs up with 9. And then I have -7 and 0. And then lastly, we have -6 and -2. So now if I see it like this, it's a lot easier. I'm going to write out my domain right here as a list of numbers. So I've got -9, -8, -7, and -6. And again, domain is my x's. Then we can look over here and we can see my range represents my y's. And I've got 8, 9, 0, -2, and then that's it for range. Okay, so let's keep going. So the next one that you're going to see is a table. Okay, let me get this. Whoops. Okay. Alrighty. Move this up. And then let's just do this. So hopefully you copied that down. It won't let me move the entire thing without it looking all crazy. So let's go from there. All right. So next we have the table. And let's do domain first. Okay, so domain, excuse me. So I'm going to list these numbers. So I've got 9, 5, 3, 10, 6, and 1. So pretty straightforward. Range, I'm going to look at my y values. I've got 9, 6, 4, 7, 6, and 2. And that represents my range. Okay, so now we're going to see a little bit different kind of graph in the sense that it has points only. Okay, so let's look at it a little bit differently. Okay, so here are my points. Okay, they're right there. And again, I think the easiest way is just to make a table. So this first point on my far left is at -2, 1. Okay, and then I have a point at 0, 0, and then I have a point at 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and remember, we always move on our x-axis first, and then our y. And then I have a point at 7, 0, and then I have another point at 7, looks like 6. Okay, so domain, those are my x's. I've got -2, 0, 5, and then 7. And I don't have to list 7 twice, but you can if you want. Okay. All right. Now, range. I've got right here. Those are my y's. And I've got 1, 0, 4, another 0, and 6. And domain and range. So again, straightforward. When I'm talking about domain, I want my x values. When we're talking about range, we talk about our y values. And these would be points on a graph shown different ways. We've got a table, we've got a mapping, we had a list of ordered pairs, and then we also had a graph. So now let's look at the other side. Okay, so we go back up here. Now we're going to list domain and range using inequality symbols. So this is a little more tough than before in the sense that you have to do it a certain way. And I would highly encourage you to get two different colored highlighters, and we're going to crop these graphs. Okay, so if you notice, even though this first graph here has an open circle, oops. So this first graph has an open circle right here, okay? And then it has a closed circle there. If they had arrows, we could still say that this is continuous, because we can count every single little point on that line and it would go on forever. So that's why we have to use inequality symbols, because it's not just an exact point, it's not a precise count. It is an infinite count, therefore it is continuous. So let's do this. The easiest way to do it, we always want to start with domain first. Okay, so domain, I am going to use a yellow highlighter to represent my domain. Okay, domain, again, we want to look at our X's. So I am going to go left to right and crop this graph. Okay, and that's why I'm going to use the highlighter. So I am going to go on the very outside edge as far as I can left. Okay, so I've given that graph a boundary. I'm going to do the exact same thing on the right side. So I have now I have now cropped my graph so that I am only looking at those points in between those boundaries. Okay, now when we write domain using inequalities, we are always going to put X right in the middle, and then we're going to have less than, less than. Okay, those are always the signs that we're going to start with. And then depending on the graph, we will go from there. So I want to see what my farthest left boundary is. So I want this point right there. Okay, so I'm at 1, 2, 3, 4, 5. I'm at a -5. That's my farthest point left. Now, because it's an open circle, I'm going to leave it just like that, where it's less than. Okay, so maybe we'll even make a note out here. Open circles, you're going to use less than or greater than. Okay, if I have closed circles, I'm going to use less than or equal to or greater than or equal to. Okay, that's why you put the line underneath it. So our farthest right boundary is at 1, 2, 3, 4, 5, 6. And since it's closed, we put a line right underneath it, and we have just represented domain using inequality symbols. And so we would read that as -5 is less than X, which is less than or equal to 6. So any number between -5 and 6 is part of this domain. Okay, so now let's do the range. And I'm going to use blue. Okay, again with a different color highlighter, I am going to represent my range. So I'm going to use blue. Now it's really important here that we go from the bottom to the top. Okay, so really, it's almost like when you crop selfies, I don't want anything outside of those boundaries. Okay. When I look at range, I go from the bottom to the top. So let's write our range. Now remember, range is our y's. So I need to do y less than less than. Okay. That's always how I start. Now, right here is my lowest point on my graph. So I need to know what value that's at. So I've got 1, 2, 3, 4, 5, 6. So it's at a -6. And again, since that graph is open, that point is not actually counted because it's open. Okay. And then my highest point up here is at a +2. And since that is closed, we would write our line underneath it. So there you go. Domain and range using inequality symbols. So let's do another example. We're going to do range first, or sorry, domain first. So again, I'm going to do it in yellow. So I'm going to go from the left farthest point on the graph. So I'm creating that boundary. And then now it's hard to see, but right there, I actually hit an arrow. Right there is an arrow. So I am not going to draw a boundary because it's telling me that on the right side, it continues on past this graph. So we could actually expand this graph over and over and over again, and it would continue on. Okay, so once I hit an arrow, I stop because there is no boundary on that side. It goes on forever. Okay, so let's do the same thing. So x less than less than. And my farthest left x is at -2. It is a closed circle, so I'm going to put a line underneath. And then now the question is, okay, well, if it goes on forever to the right, what do we put? And the answer is we put an infinity symbol. So basically that is saying that my domain is -2 and then everything to the right of it. Okay. You might also see them put all real numbers greater than or equal to -2. Okay. Because again, all of these numbers to the right or bigger than -2 work. Let's do range. Okay. I'm going to go from the bottom to the top. Now, again, the problem is right here, I hit that arrow. So there is no upper boundary. It would continue on forever. So when I write my range, I've got y less than less than. It's where we always start. And I need to figure out what my lowest point is. So I've got 1, 2, 3, 4, 5. So it's at -5. It's a closed circle. So I'm going to put that line underneath. And then just like we did for domain, it's going to go on forever. So I put that infinity sign. So this one was domain. And please make sure you write this down because you will see it as words. And so it's really important not only that you can write it using inequalities, but that you can translate that inequality to words. So let's do that. So the range for this one would be all real numbers greater than or equal to -5. So again, everything to the right is good, and then everything up is good. Okay. I strongly, strongly, strongly suggest that you do the 2 highlighters and that you crop these graphs. If you can do that, then you will have no problem. Okay. So I'm going to go ahead and erase this part. We have 2 more examples, and then we will cover some stuff on the back just as more practice problems. Okay. Um, Domain and range is a really big concept in Algebra 1. So please, 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 if you have questions, please let me know. That way we can look at it together, especially if you are not with me today in class. All right, let's do domain and range. Okay. Let me scroll up a little bit. Okay, there we go. All right, so this third graph, oh, did we start on the first one? Oh, no, there's only 3. Okay, thought there were 2. So we only have one more example. All right, so here I have, and I know it's hard to see, but these are actually arrows. So if you can't see them on your graph, please fill those in, because it's really important anytime you see an arrow that you know what to do. Okay, so we're going to do domain first. I'm going to use yellow to highlight it. So here's the deal. Now I'm trying to make my left boundary, but what do I hit? Well, I hit an arrow. Okay, so I stop. So that arrow, I stop, because on the left-hand side, there isn't a boundary. That arrow tells me that it goes on forever. Okay, so I'm going to do the same thing on the right, but again, the same thing happens. I hit an arrow, so that side goes on forever. When we write the domain, well, if I did x equals less than, well, on the left-hand side, it would be going off to negative infinity. On the right side, it would continue on going on forever to positive infinity. So really, the domain for this one, or my x's, are all real numbers. Okay, means it goes on forever to the left and the right. So now let's look at our range, and that's our y's. Okay, so I go from the bottom to the top. I have a boundary at the bottom. Okay, and then once I try to make my boundary up here, the same thing happens. I run into these arrows, which means that it's continuing on up and up and up forever. So I've got y less than, less than. So what is my lowest boundary for my y's? Well, it's at -1, 2, 3. So -3. And since it is a closed circle, I'm going to put that line underneath it. Now, I cannot crop it to the top, so it goes on forever to positive infinity. And we could say that my range is all real numbers greater than or equal to -3. Okay, oops, can't see that. There we go. Okay, so that's really it with domain and range. Just make sure that you understand domain represents your x's, and you always want to go from the left to the right, because you want the left side, the negative side, that will always come first. And then for range, you want to go from the bottom to the top. Okay. So I am going to go ahead and get ready for the second part of the video. But make sure that you have your notes filled out. And again, like I said, if you have any questions, please email me. All right, bye.